Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about a new data structure which is called as sets. Now first of all we'll see the definition of sets, and we'll see a lot of example along with methods and what is the importance of sets altogether. But one of the most common data structures, we specifically use sets after probably list and dictionaries and tuples, right? So that is the reason why I'm covering this data structure. So we'll be seeing a lot of examples in short. So first of all, let's go ahead with the definition. So here you can actually see sets are built-in data types in Python used to store collection of unique items. They are unordered, meaning that the elements do not follow a specific order and they do not allow duplicate elements. So they are some of the very important points. So please make sure that before you start any of the lessons, see the definition. Sets are useful for membership test, eliminating duplicate entries, performing mathematical set operations like union, intersection, differences, and semantic differences. Now all these things what we have actually learned we'll see with the help of practical example. So first of all, I'll go ahead and make a lot of cells over here. Okay, so let's start. So first of all, the first thing that we are going to discuss is how to create a set. Okay, and creating a set is specifically using curly braces like how we actually did in the dictionary, but only one difference that is present between sets and dictionary is that in dictionary we usually give key value pairs, right? So let's say if I am going to define my underscore set over here. Okay, so I will just go ahead and use curly braces and I'll just go ahead and write 1 2 3 4 5 elements. Okay, and if I go ahead and print my set over here and also see the type of print type of my set, then here you'll be able to see that hey, I'm able to get it over here something like this. See, so all the elements is basically getting displayed, and over here you can actually see that it is a class set. Okay, now if I also want to go ahead and create my empty set, so here I can go ahead and write my empty underscore set. Okay, I can directly use the class. Okay, something like this. So if I go ahead and create like this, then I am going to get my empty set itself, right? So I'll just go ahead and print it. So here you can see the type is nothing but it is a class set, but since I've not put up any elements, so over here you'll be able to see that it will be an empty set. Now along with this, what I will do, I will just go ahead and copy this, and let's say that inside this set I can give tuples, I can give list, and also if I go ahead and give 1 2 3 4 5 6, I will probably execute this also. Okay, so let's go ahead and print this right now over here. Okay, and let's see the sets, right? So this is one of the most easy way, probably take a list or a tuple and just typecast with the help of set class, right? And here you'll be able to see that I will be able to get the set. Now one of the functionality that I've actually told you over here, right? Sets are nothing but it is built-in data type used to store collection of unique items. Okay, so what does this basically mean? So if I go ahead and copy this and execute it, so let's say this is my set itself. I'll not say my empty set because now we have elements. Okay, and here also I will just go ahead and remove this. So let's say that this is my set, right? Now let me just go ahead and write some duplicate elements. Let's say over here I'll go ahead and write 6, 5, 4, 5, 6, right? Now, even though I have duplicate elements, what it is going to do is that it is just going to ignore the duplicate elements and take only one element of the similar type, right? So here you can see 6 and 5 are duplicate elements. So what it will do, it will just display one time 5 and 6. So if I go ahead and execute it, here you can see that I'm getting 1 2 3 4 5 6, right? And as said over here, you can see they are unordered, meaning that the elements do not follow a specific order and they do not allow duplicate elements. Okay, sets are useful for membership test and all. We will have a look onto that. Okay, so now let's go ahead with some of the basic set operations. Okay, basic set operations. Okay, now with respect to basic set operation, the first thing that I am going to show you is adding and removing elements. Okay, adding and removing elements. Now in order to add and remove the elements, I can probably, let's say this is my underscore set over here. Let's say I want to add more elements over here, right? And then I'll try to print it. So for that, what I have to do is that go ahead and use my add method. And let's say here I want to add a specific element over here. Let's say 7, I want to go ahead and add it. And I will just go ahead and print my underscore set. Okay, so if I go ahead and execute it, here you'll be able to see 1 2 3 4 5 6. Okay, similarly if I go ahead and add the same element, okay, then you know what it will happen. Then it is just going to ignore the repeated elements because I have already added that in the set. So here also you'll be able to see that I'm going to get 1, 2, 3, 4, 5, 6. Okay. Now coming to the removing the elements. So in order to remove the elements from a set, okay, from a set, so what I'm actually going to do, I'll just go ahead and write my underscore set dot remove. Okay, my underscore set dot remove, and here I'm going to specifically use one element, let's say 3, and I'll just go ahead and print my underscore set, and now here you can see that the third element is already not present. Okay, let's say what happens if I try to remove an element which is not present at all. Okay, so for that let's say I'll go ahead and write my underscore set dot remove. Okay, remove of element 10. Okay, so if I go ahead and execute it, it shows that hey, there is a key error because I don't have that specific element. Okay, now there may be scenario that I need to have a scenario that if an element is not present in the set, it should not give us an error. Okay, it should just continue. If there is an element, it should remove, otherwise it should not give us an error. So for that, what I will do, I will just go ahead and run my underscore set dot discard, and let's say inside this I'm going to remove an element called as 10 or 11, whatever. And if I go ahead and execute it, here you'll be able to see that I'm not getting any error, right? Even though I go ahead and print it, right? So print my underscore set over here, and here you can see 1, 2, 3, 5, 6, 7. So that basically means if I'm using this discard method, right, it will just go ahead and see, remove an element from a set if it is a member, right? If that particular element is there, it will remove, otherwise it will just make sure that it will not give us an error. Okay, now removing a random element, right, using pop. So here we also have something called as pop method. Let's see what is exactly this pop method, right? So for pop method, I will just go ahead and write, this is my removed element. Okay, and then I will just go ahead and write my underscore set dot remove, dot pop, my underscore set dot pop. Okay, and what I'm actually going to do, I'm just going ahead and display my print removed element. First of all, print removed element, and then I'm also going to print my underscore set. Okay, so here if I probably go ahead and display it, right? So over here you can see with respect to set, it is just like first in first out, right? So whatever element is first inserted, that element only will get removed. So that is the reason why I'm getting is something like 2, 4, 5, 6, 7. Okay, so here you can see that whenever I have an element, I should be able to remove it just by using pop, and I will also be able to get the element itself. Okay, and finally, if you really want to clear all the elements, okay, all the elements, you can just go ahead and write my underscore set dot clear. Perfect. And here you can go ahead and just print the set. Okay, so this will basically be my print my underscore set. Perfect. So if you see this, and if I execute it, here you can see that I'm actually getting a empty set altogether. Okay, now let's go ahead and see some more examples. So first of all, I'm going to show you set membership test. Okay, membership test. Okay, now with respect to membership test, it's just like whether an element is present in the test or not, whether an element is a member of a set or not. That is what we will basically check. So I'm going to write for my underscore set is nothing but 1, 2, 3, 4, 5, and here I will just go ahead and write print, let's say, and if here we'll use an in operation, right? Let's say I'll take an element 3 in my underscore set, right? So here if I go ahead and print it, or if I go ahead and print 10 in my underscore set, right? So if the element is basically present in set, it is just going to give us true, otherwise it is going to give us false. So that is the reason here you can see when I'm checking whether 10 is present in my set or not, I'm actually getting false. But when I'm checking 3 is in my set or not, so here I'm actually getting true, right? So that is the reason it's just checking whether this particular element belongs to that particular member or not. Now let's go ahead and see some more mathematical operations. Okay, now in this particular case, let's say I go ahead and create my set 1. Let's say it will be 1, 2, 3, 4, 4. Okay, I'll have 4 elements. Okay, just to give you an idea over here, and or let me just go ahead and write something like this: 4, 5, 6. Let me just add more element, and this will be set 2. Okay, now inside this set 2, let me just go ahead and write from 4, let's say 4, 5, 6, 7, 8, 9. Okay, so these are my basically all the elements. So first operation that we are basically going to discuss is nothing but union. Union basically means when I have two sets, I'll just combine all the elements, right? So in order to get the entire union set, so here in set also you will be able to see that I will be having a lot of inbuilt methods. Okay, so there is something like difference update, and is lower is this is there, and let's say symmetric difference is there, symmetric difference update is there, union is there. So I'm just going to write say set1 dot union, and here I'm going to specifically use set2. Right now, if I go ahead and print my union underscore set, you will be able to see that I will be able to get the output. So I'm getting an error because of syntax. So here you can see all the elements has been combined. Union basically means you're combining everything. Okay, so 1 2 3 4 5 6 7 8 9. Okay, so this is one of the operation, most common operation that we do in sets. The next operation that we are basically going to do is something called as intersection. Now intersection is nothing but it will basically give us a common set, common elements from both the sets, right? So here I'm going to probably create the intersection underscore set. Let's say I'll just go ahead and write so here you can see set1 dot intersection of whatever y will not be there. Here I will just go ahead and write set2. Okay, set2. Okay, set2. Okay, now if I go ahead and print my intersection set, so here let's go ahead and see this intersection set. Here we'll be able to see only the common elements it will be able to give. So 4 5 6 are common, available in both the sets, so that is the reason it is basically getting displayed. Let's see one more operation. I don't know whether it is present or not. It is called as union. Okay, so only union is present over there, no worries. Okay, let's do one more thing. Let me just go ahead and write something like this, set1. Okay, set1 dot intersection update. Okay, so we'll try to see this. Okay, what is this function called as intersection update? Okay, and here I'm basically going to give set2. Okay, so here the kind of operations that we are actually doing, and if I go ahead and print my set1, okay, if I'm going ahead and printing my set1, please focus on this. Okay, let's see this. What will be the third print, right? First print, you know, it will be the union. Second print will be the intersection, and third print whenever we use intersection underscore update of set2. Now if I just go ahead and print it, here you will be able to see now when we did this intersection underscore update, so whatever are the common elements from set1 and set2, that we got it, and that all elements got updated in set1. That is most important that you really need to understand over here. Intersection underscore update basically means whatever operation, specifically intersection we are doing over here, it will just find out the common elements and it will update in the set1. So that is the reason I'm actually able to get 4 5 6 when I'm printing set1. Okay, so please make sure that you keep this in mind, and whenever we do intersection or difference, there will also be a difference underscore update, intersection underscore update altogether, right? So this is why I have actually showed you one example. Okay, so please make sure that any operation underscore update basically means we'll perform that operation and we'll update in one of the set itself, right? So I will go ahead and create my another set1 and set2. Now this time let me go ahead and create difference, right? Difference operation, let's discuss. So if I go ahead and write set1 dot difference of, again I don't know why this is giving us x and y, I think by default it is taking us, and then we go ahead and write set1 dot difference of set2. Now if I go ahead and print the element of this. Okay, so here you will be able to see set1 minus difference of set2, set1 dot difference of set2. That basically means from set1 we will remove the common elements that are present in set2. So here you can see 4 5 6 has been removed, and here I'm actually able to get the output as 1 2 3. Okay, there is also one method, as I said, difference underscore update. Difference underscore update basically means it will perform that operation difference and it will update in the set1. So in set1 I will be able to see right now it is if I probably see right now, it is set1 is nothing but it is having all these elements 1 2 3 4 5 6. But when I do difference underscore update, there is a method over here. It is going to make sure that it updates this difference operation, whatever output is coming in set1. Okay, this is the basic difference. Now let's do one more thing, and again see, if I want to remove all the common elements from set2, I can also go ahead and write something like this, set2 dot difference, set2 dot difference over here, And here I will just go ahead and write my set1. So whatever is my element that is available in whatever is my unique elements or remaining elements in set2, and set1 elements has been removed because 4, 5, 6 is the common element over here, right? And that is the reason I'm actually getting it over here, right? So I hope you are able to understand till here and all. One more operation that we are going to discuss is nothing but symmetric difference. Okay, and let's see whether you will be able to understand what exactly this is. So if I go ahead and write set1 dot symmetric difference, okay, of set2. Okay, let's see. Now if I go ahead and execute it, here I am able to get 1, 2, 3, 7, 8, 9. That basically means both the unique elements from both the sets are combined. Common elements are just removed. Okay. So these were some of the mathematical operations that we probably perform. Again, I will repeat it. Symmetrical difference is nothing but from set 1 and set 2, which are the common elements, only that will be removed, and remaining all the unique elements from both the set will be combined. Okay. So that basically the intersection elements is just removed over there. Okay. So that is what symmetric difference basically means. And you can also do the vice versa, set2 dot symmetric underscore difference of set1. You'll be able to get the same answer. Okay. Now let's do one thing. Let me go ahead and make some more cell. Okay. I'll go ahead and make some more cell, and let's discuss about some of the sets methods. Okay. Again, important one. You may be using some or the other thing over here, right? So first of all, I will just go ahead and create my set1, and let's say I'm going to write 1, 2, 3. Okay. 3 elements are there. In set2, I'm just going to write 3, 4, 5, right? Now, first of all, we will go ahead and see what is subset. Okay, is subset. Now, with respect to is subset, I will just go ahead and print set1 dot is subset. Okay, set1 dot is subset of set2. Okay. Now, once I do this, you will be able to see we are just checking whether set1 is a subset of set2 or not. Is subset basically means all the elements that is present in set1, is it also available in set2? Is this the parent I can just say, is it the parent set which has all the elements of set1? So right now here you can see that I don't have it, right? Because set1 is not available. One of the element is also not available in set2, right? So if I just go ahead and execute it, here you can see it is false. Okay. The next one is just to check whether set1 is the superset of set2. Okay. So if I go ahead and write set1 is superset of set2. Is it a superset of set2? I'll just go ahead and print it, and here you will be able to see that I will be able to get the answer. So here right now it is false. Again, set1 is not a superset of set2. It checks if set1 is a superset. Superset basically whether it has all the elements of set2 or not. Okay, so this is also false because it does not. Let's say if I go ahead and write like this 3, 4, 5. Now if I execute it, here you can see set1 is not subset of set2 because here there are more elements. But if I go ahead and write set1 is superset of set2 because this 3, 4, 5 is also available over here, you can actually see, right? If I just remove 5 also, then also you'll be able to see both are false, right? It should at least have all the elements from either one of the set. Okay. So this is what is an example with respect to some of the methods that we use. Is set, is superset, and again guys, there are a lot of methods that are available in sets which you should definitely keep on practicing and keep on seeing. Okay. Now let's do one kind of task. Okay. So here let's say I have some numbers. Okay. I have a list. Okay, list, and with respect to this list, I will just go ahead and run 1, 2, 2, let's say 3, 4, 4, 5. Okay, so these are my elements. Okay, now if I just want to quickly remove the duplicates from this list, okay, from this list, what I can do, I just have to convert this into a set. So if I go ahead and write set of listy, here you'll be able to see, hey, I am going to get all my unique elements 1, 2, 3, 4, 5, right? So simple it is. If question is basically asked whether you really need to find out a list of elements, you can basically do that. Okay. Now let's do one practical example here. What I'm actually going to do is that I'll just go ahead and write counting unique words in text. Let's say if I have a sentence, text. In this tutorial, we are discussing about sets. Okay. So here it is. So I will just go ahead and I need to basically count unique words in text, how many unique words are basically there, and then we can basically do that. Very much simple. So here, first of all, what I will do, I will just go ahead and create a variable words. I will take this text and I will do the entire split. Okay, I will get all the elements over here with respect to the split, and then you will be able to see convert list of words to set. Okay, to get unique words. Okay, unique underscore words. Okay, unique underscore words, how do we get it? We just need to use set of all these words. Okay, whatever words we are specifically giving. Okay, so once I get the unique words, I will just go ahead and print it, print unique words, and then after that I'm also going to print the length of the unique words. Length function is there, and let's go ahead and write length of unique words. Okay, if I go ahead and execute, so tutorial we discussing this in about sets are, right? So 8 unique words are specifically there, and here you can actually see that how I actually printed it, right? Simple. So I hope you liked this particular video with respect to sets. We have almost discussed each and everything, like common key methods, errors, what kind of errors you feel, and what are the common functionalities, methods with respect to the sets. So I hope you were able to understand this particular session. I will see you all in the next video. Thank you. Take care.